we would like to compute the integral of z bar dz along the contour C, where C is first the line segment from 0 to 1 plus I, and second, the unit circle traversed counterclockwise. So in part A, in general, if you have a line segment whose initial point is z1 and whose terminal point is z2, then the parameterization is gamma of t equals 1 minus t times z1 plus t times z2, where t goes between 0 and 1. So in our case, the parameterization is z equals gamma of t equals 1 minus t times 0 plus t times 1 plus I. And that simplifies to just 1 plus I, t times 1 plus I, and then t goes between 0 and 1. Then in general, to compute an integral of f of z dz along the contour C, we have to integrate a to b f of gamma of t times gamma prime of t dt, where the a and the b are the endpoints, the bounds for the parameter. So in our case, the integral of z bar dz will equal the integral from 0 to 1 of, our function is the conjugate function, so f of gamma of t is gamma of t quantity bar, and then gamma prime of t dt. So here's gamma of t. The conjugate is t times 1 minus I, and gamma prime of t is the constant 1 plus I, and this integral is t times, here we have to FOIL, and it's a minus b times a plus b, so it's a squared minus b squared, and that's 1 minus I squared, which is 1 plus 1, which is 2. So this product is 2. So we want to integrate 2t from 0 to 1 dt. The antiderivative is t squared. So 1 squared minus 0 squared, and the answer is 1. So in part A, the integral is equal to 1. In part B, we want to integrate around the unit circle. The unit circle can be parameterized by z equals gamma of t equals cosine t plus I sine t, where t goes between 0 and 2 pi. And this can be abbreviated as e to the it. So we want to integrate z bar. So the endpoints are 0 and 2 pi for our parameter t, the bounds for the parameter t, 0 and 2 pi. E to the it bar times the derivative of e to the it, which is e to the it times I. Now e to the it times e to the it bar, any z times z bar is the magnitude of z squared, and the magnitude of e to the it is 1. So this is just the integral from 0 to 2 pi of 1 times I, which is I dt, and so that's 2 pi I.